Stars are amazing balls of hot gas. They twinkle in the night sky. But did you know that stars have a life cycle just like us? They are born, they live, and they die. The most important factor determining a star's life is its mass. Big, heavy stars live fast and die young. Smaller stars live much longer, quieter lives. Understanding the life cycle of stars helps us grasp our place in the universe. In the next sections, we will take a journey through the different stages of a star's life. Stars are born in giant clouds of gas and dust called nebulae. These nebulae are like cosmic nurseries filled with the raw materials needed to create stars. Within these nebulae, gravity acts as a sculptor, pulling the gas and dust together. As more material clumps together, the center of the cloud gets denser and hotter. Eventually, the core of the protostar becomes so hot and dense that nuclear fusion begins. This energy release is what makes a star shine. The protostar has now become a true star, radiating light and heat out into the universe. The main sequence is where a star spends most of its life. Our own sun is currently in its main sequence phase. During this phase, a star is in a state of equilibrium. The outward pressure from the nuclear fusion in its core balances the inward pull of gravity. This balance keeps a star stable and shining brightly for millions or even billions of years. Eventually, the star will run out of hydrogen fuel. When this happens, the star enters a new phase of its life cycle. As a low-mass star, like our Sun, runs out of hydrogen in its core, the outward pressure from fusion lessens. Gravity starts to win the tug of war. The core of the star begins to contract, becoming denser and hotter. This increase in core temperature heats up the outer layers of the star, causing them to expand outward. As the star expands, it cools and turns red. The star has now become a red giant. Eventually, a red giant will shed its outer layers into space, creating a beautiful glowing cloud of gas and dust called a planetary nebula. The remaining core of the star, now incredibly dense and hot, is called a white dwarf. White dwarfs no longer produce energy through fusion, but continue to glow faintly as they cool down over billions of years. Massive stars have a much more dramatic end to their lives. When a massive star runs out of hydrogen in its core, it starts fusing heavier elements like helium, carbon, and oxygen. This process releases even more energy, causing the star to swell into a supergiant. Eventually, the star's core will be filled with iron, an element that cannot be fused to produce energy. When this happens, the core collapses in on itself in a matter of seconds. This collapse triggers a shock wave that blasts the star's outer layers into space in a brilliant explosion called a supernova. If the core is massive enough, it will collapse further, forming a black hole. If the core is not massive enough to form a black hole, it will become a neutron star, an incredibly dense object composed almost entirely of neutrons.